Hello everyone, today we're going to solve this integral of x cubed square root of 1 minus x squared dx. Now, in order to solve this, an easier way to do it would just be using a trig substitution, and recall that this layout looks like this, and this will be a sine theta is equal to x. Okay, so then 1 sine theta is equal to x. I got the 1 here from here. Now, the dx of this is cosine theta d theta. Now we can plug this in. So sine cube theta, remember we got that from the substitution over here, square root of 1 minus sine squared theta, and we're going to use this right here, cosine theta d theta. And now we could just simplify this even further and go sine cube theta square root of cosine squared theta. Remember, 1 minus sine squared theta is just cosine squared theta. It is an identity. Times cosine theta d theta. We can actually, let me rewrite this. Cosine squared theta. We can actually rewrite this term right here, since the square root and the square will cancel out. So we can write this as sine cube theta cosine. This will just be cosine. And I'm multiplying it with another cosine theta d theta, which will make that cosine squared theta down here, d theta. And now we can further simplify this term right here. We can split that, and it'll be integral of sine squared theta times the sine theta times cosine squared theta d theta. Now, this term can actually be changed to 1 minus cosine squared theta because of the identity. Now, from this point on, I'm going to use a u sub. So we will use cosine. So the derivative of that is negative sine theta d theta. And in order to solve or put it in terms of d theta, you will just move the negative sign over here, and that's your term, so you have it in terms of d theta. Now, or du. Now, this sign will actually cancel out this one right here. But don't forget the negative, so we put it in front, and this will be 1 minus u squared times u squared du. Remember, these terms come from this substitution, and we add the squares because there's squares here. Now, we distribute this, and we get alright, and our integral will be u cubed over 3 minus u fifth over 5. sorry, there's no. So, and then you distribute the negative. Don't forget about the negative. So negative u3, u cubed over 3 minus, or plus u5 over 5 plus c. And if we undo the substitution, remember we used u as cosine, we're going to get cosine cubed theta over 3 plus cosine fifth theta over 5 plus c. Sorry, negative here. So we got to this point. However, we will need to put it in terms of x squared. So what we need to do is we have to have a triangle, and here we already started here in this section. We stated that one sine theta is equal to x, or sine is equal to x over 1. So Katoa is opposite over hypotenuse. So that would make this 1, this x. Now, in order to find the adjacent, we would need to use the Pythagorean theorem to find a. Right? And so we will just solve for a. And 1 squared is just 1. So we will now take the square root of that, and it is 1 minus x squared. So this is 1 minus x squared. So the cosine is 1 over negative x. Oh, sorry, subtract x squared. And now we will plug this in to this formula, or this integral that we got, and it'll be 1 minus x squared, square root of that, to the third power, 3, plus, oh, remember this is a negative because we distributed the negative, plus 1, square root of 1 minus x squared to the 5th power over 5 plus c. Remember the c because we don't have, this is an indefinite integral, and this will be your answer.